Hi, so what is data visualization? Well, in this course we're going to look at the ideas of data visualization, what it is, how we produce visualizations, and why we use it in the first place. What benefits might data visualization have for us? So this is an image here which is a visualization of visualization itself. It's an attempt to illustrate the process of producing and seeing and understanding visualization. It looks at, on the left, a representation of a cloud of data. So a cloud of data is somewhere where we're storing some data. And it could be in a remote server, it could be locally. This data is accessed and streamed to some analytics devices. And the visualization software that we'll produce in the course is going to convert these data items into geometric items, into visual cues such as color or shape or shading or texture. And these are then rendered to produce pixels, which are shown on the screen. And here's one visualization from a short film we did for Newcastle. Once the pixels are on the screen, the display device, which might be a monitor like here, or a headset, an AR or VR headset, or a big projection screen, produces light. So light's visible electromagnetic radiation, which conveys the information on the screen to the viewer. And in this case, the viewer sees this and the light's detected by their retina, and that sends neural signals into the brain where this is converted and understood. The way the mind works, it processes the information in this visual signal. It tries to understand the meaning of this visual signal, and both the perception and the cognition of visual signals, as well as hearing and touch and other senses, are studied in psychology in great depth in vision science for visual signals. Producing high quality visualizations is complex because it requires you to understand both the computational side of this visualization and also the human perception side, where people are not the same as machines in the way in which they process information. So in addition to this, the size and complexity of data stored in the world is constantly increasing, while human cognitive abilities are static. So visualization producers such as us need to be constantly able to adapt between ever-increasing amounts of data in the world that are measured or simulated or synthesized in models, for example, models of pandemic outbreaks, and the relatively fixed capacities of the human visual system. Although we understand more about that all the time, certainly our understanding of how to visualize data isn't changing anywhere near as fast as the amount of data in the world that we want to visualize. So why use data visualization? So visual understanding was looked at in about 1800 by Pestalozzi in Switzerland. He said visual understanding is the essential and only true means of teaching how to judge things correctly. The learning of numbers and language must definitely be subordinated. This might be a very old quote of no relevance, except for one thing. He set up a series of schools which taught a visual learning method, and this visual learning method was taught to Einstein. And Einstein, in his later life, said that he always needed to try and visualize ideas, see them in his mind, before he wrote down formal mathematical descriptions of them. John Tukey, in about 1977, very famous statistician, wrote a book called Exploratory Data Analysis, said the greatest value of a picture is when it forces us to notice what we never expected to see. And if only I had a pound or a dollar or a yen for every time someone said that about a picture we've created, I wouldn't need to work anymore, really. But Tukey became very well known both for something called box plots, which we'll look at, and prior to that, Mary Eleanor Spear described something very similar called the range bar in her book called Charting Statistics in the 1960s. So it was a very critical time, the 60s, 70s and 80s, for the beginnings of modern data visualization. If you look at what the aim of visualization is, it's to accelerate through this data, information, knowledge, wisdom pyramid. This isn't a great model of how we think, but it's a model and it's a widely used model. And our goal here is to make data more intelligible to people, but it also helps save time So if you can make a visual presentation that's easier to understand, that's quicker to understand, you save people time, and time very often is money, and that's what saves them effort and cost in coming to understanding from their data sets. And it can make what is otherwise unintelligible data highly intelligible. So if you look at a very complex spreadsheet, you're not really going to understand all the details by looking at the spreadsheet, but you may well by looking at the image of the data, a carefully designed visualization. There's a long history of supporting cognition using designed images. On the left here is Florence Nightingale's famous coxcomb diagram from 165 years ago. And these plots were used to convey information about the Crimean War and the hospitalization of patients through to generals making decisions. It turned out that more people were dying in hospitals than were dying in the war, and at that point they started to fix hospitals rather than wage more war. Her famous quote, "To affect through the eyes what we fail to convey to the public through their wordproof ears." If we move on to the 1930s, Otto and Marie Neurath created the Vienna method for pictorial statistics, later known as isotype, and that used these kind of very iconic precursor to today's emoticons and icons on phones. This is a demonstration of how home-based weaving changed entirely into factory-based weaving in the Industrial Revolution in England. So, what's the truth you see in data? This is an animation which will show you different ways of seeing the same thing. So you'll see three projections of a shape. It's illuminated by three artificial light sources. And you can see, depending on which projection you see, you either see this kind of lemon-shaped, circular shape rotating, you see a square or a triangle, or a square turning into a triangle, and the other two projections. Whereas the original shape itself is like the tip of a flat-bladed screwdriver, and is not really represented that well by any of the 2D projections. So when you visualize data, it's really important to consider the context of data collection, look at any missing data or any distortions in the data that your analysis has generated along the way. Okay, thanks for now.